Hello friends, welcome to our mysterious expedition through the black hole. In the first part of this video we have answered what is actually a black hole. In this part we will answer why is it considered so mysterious. So let's get into it. By the way, if you haven't seen the first part of this video, go check it out. The link is in the description below. So let's come back to the point. Why black holes are considered so mysterious is because of the space and time continuum that it does. If you know Einstein's special and foremost theory of relativity and the formula of E equals to mc square, this will be a whole lot easier to you to understand. That is, when any kind of mass creates a kind of curve or a kind of curvature in any kind of sheet or kind of space, you can say. So you can understand that when any kind of space and time they curve each other, not they curve each other but the mass curves them. Together space and time are known as space-time and you can't actually differ them. I will describe it later on this video. These two are the normal, the basic logic and the forces of the universe. So here consider, the earth has a mass and it is creating in the sheet of the space. So you can see it is creating a curve in the sheet of space, where the moon is creating less curve because its mass is less. So we can understand that this curve is fully dependent on the mass and gravitation of an object, because this place is plane but where there is the mass, it is curved. Again, you can see here the sun creates more curves than the earth because the mass of sun is way more than earth. I have said it in the solar system sequel of my channel. You can go and see it. So now you can understand the space and time toward the main objects and the main theories of the universe, but they can't actually be differentiated. And together they are known as space-time. So why they can't be differentiated? Let's think like this. You have a glass of water and you have red color. Now you take red color and mix it with the glass. After some time you will see that the water has turned red. Now if you see that this is just red color, if you even take a spoon of the water, it is just red water. It's not water and red color separately. Now it's just red color. Yeah, I know that this can be indivisible with each other by going into molecular level, but I'm just trying to show you the basic things. The same goes with space and time. Space and time are indivisible and in no way you can divide them, not even in a molecular level or any kind of smaller level. In no level you can divide them, and so they together are known as space-time, the basic logic of the universe. So space-time is actually a very complex object of physics, because space and time is curved by the black hole. Now the question might arise that how does a black hole curve space and time, which we know now is space-time. So let's get into it. How does it curve that? Due to this curvature, 1 minute inside or near a black hole can be equals to years outside of it. How is it possible, you may ask? Just think that the black hole's time is way slower than the normal time. How is this possible? This can be made due to different kinds of reasons. Suppose that if you jump into a black hole and for a distant observer, they will think like you are just freezed. Though for you, you do your normal activities that you do and you go through the time that you normally go through. Though inside a black hole you are actually. But why will they think we are frozen and how will we even survive so long? And why does the question of surviving comes in? Suppose that you live 1 year into a black hole or a few hours into a black hole, just a few hours, and when you come back from a black hole, you see that there has been more than thousands of years outside a black hole. So how is this possible? And how will we even survive this long, thousands and 500s of years? So here the theory goes. Everything that we do from birth to death, our evolution from the primates to humans, even the evolution of Earth from a dusty and rocky and very hot planet, from the creation of the solar system to the present day, all these go through one thing, time, space-time continuum. So consider this. When you are in Earth, you go through the time of the Earth, which is a little bit slower than that of other space bodies. By other, I don't mean other space bodies, but actually the vacuum of space. But it is so slow that even it is hard to feel any difference. Even you can't feel any difference because the gravity of Earth is not enough to feel any difference. But when you are in a black hole, the gravity of it is immense and it curves space and time at such a level that the time slows so much it can be just seems like frozen. So consider this. You go inside a black hole and go with a normal routine work. For you are just doing your work like you do outside a black hole, but for a distant observer, they will feel like you're frozen. You are not actually frozen, but it is very slow. Just think of a object that is moving at a speed of 1 centimeter per day. It will seem like it's just frozen, right? The same goes with black holes. The time is so slow that it is almost impossible to understand. But even going inside a black hole is not too easy. You have to go through the process of spaghettification in order to go through a black hole. And it is not so good to say. In this process, a man or whatever the guy is going inside a black hole will be first stretched so much that it's almost impossible to survive. Just think like this. The good news here is in this process of spaghettification, you will be taller than the Eiffel Tower and you will feel so tall. It's amazing, but the bad news here will be it will be thinner than a human hair because it has stretched you so much that all your mass and whatever you have has gone towards your length and now you're very thin, extremely thin, even thinner than a human hair. You can be as thin as a microorganism or cell. So let's come to the black hole stuff. In the previous part of this video, I have told you about the event horizon, aka the point of no return. So when you pass the event horizon, you can't just come back, and after it, you just go towards the singularity. This is the point of singularity which has been thinking and which has been confusing the scientists. Scientists still don't understand what happens to an object when it passes the point of singularity. Is a portal or anything? To a portal to other universes? No one knows for sure because nothing comes back after going towards a black hole. So in this part we have said you why black holes are so mysterious. In the third part of this video we will tell you all the possible discoveries by a black hole and why that makes a black hole more mysterious. So with that, that's all for today and goodbye. Also see the other parts of our channel and don't worry, they will come soon.